Hello, welcome back to Emoji Economics. My name is Onole Godwin. The class that preceded this, we were talking about multiplication of matrices. Actually, not that. We're talking about the determinant of matrices. Okay, yeah, determinant of matrices, and we're talking about I think 3 to 4 things now: introduction to matrices, subtraction and addition, multiplication, determinants, and this should be the 5th class on the matrices. Okay. So if you want to follow up on our classes, just check the description below and click on the link. There is a link there that says if you want more of our classes, so you click on that link. Then the link takes you to the page, the Emoji Economics page. So you just go to playlist. By the time you go to playlist, then you see the playlist of matrices. You click it and you continue. The other thing that you could do is to just scroll to the end of or watch this video till the end. Then a playlist is going to be suggested to you at the end of it. You click on that. It's going to be a matrix playlist anyway. You click on that and you get to the class we've done before. And if you happen to see this class when we've done several other classes on matrices, okay, you are going to see other classes that we've had again. Alright, so today we will be talking about minors, cofactors, transpose and adjoints of a matrix. Actually, I have to put them together because they are basically interrelated. Okay, in order to get the adjoint, you need to have the transpose of the cofactor. In order to get the cofactor, you need to have the minor. Alright, so why not just talk about everything in the same video? Now, what is a minor? A minor is the determinant of a square matrix. So the matrix has to be a square matrix for you to be able to have a minor of it. Now, a minor is the determinant of a square matrix formed by deleting one row and one column from a bigger matrix. Alright, so which is to tell you that you can't really find a minor of a 2 by 2 matrix, because by the time you delete one row and one column, so what do you have left? So let's say you have x, y, z, p. Alright, and you delete these and these. So what then do you have left? So this is that a minor? Alright. Okay, because the minor has to be the determinant of a square matrix. So P is not the determinant in this case. Okay, this is not how to get determinant. At least we proved that when we're talking about determinants in the previous video. Alright, so that is why you can't find minors for a 2 by 2 matrix. That starts from a 3 by 3, 4 by 4, and all of that. Now let us start. So what does deletion mean? What does deletion mean? Now I've written the same matrix in 3 places just because I want to show or something. It isn't going to be written like this in other situations. So, but let's just get the basic thing that we need to get from this particular video. Now this is A11, right? Right. If you are looking for matrix M11, if you are looking for minor M11 right now, alright, so it is written this way. All you just have to do is to delete where A11 is. We delete it like this. We delete it like this. So what are we left with? We are left with A22. So that is what we call by deletion of a row and a column. A32 and then A33. Actually, this is not the end of it all. This is not the end. So minor now is going to be, how do you get determinants? Then you multiply elements on the principal diagonal and subtract the element from the off principal diagonals, and that's going to give you answer. So this A22 multiplied by A33 minus A32 multiplied by A23. So whatever this gives us is going to be M11. It's going to be, don't worry, I'm going to be solving mathematical examples, numerical examples, let me say, numerical examples to make us understand this. What if we are looking for minor M12? So which simply means the first row and the second column, right? So and that is going to be for this guy. So which is A12 here. So we strike this out, strike this column out, we strike this row out, and we are left with A21, A23, A31, and then we are left with A33. So all we just have to do is, okay, this then becomes A22 times A33, A21 rather, times A33, then minus A31, A23, A31, A23. So whatever we get here is going to be our M12. Now let's do for M13 now. Alright, and that's going to give us, now where is 1? Okay, don't let me even say M13. Let me say M23, for example. The second row and the third column. Which is, this is the second row and the third column, right? So let's try this out. So we strike this out. Alright, and we are left with what? A11, A12, A31, and A32. So how do we find this? So we're having A11, A32 minus A31, A12. Alright, so if I'm not mistaken, so that's all. That's how to find the minus of a matrix. So we do that for, we have 9 elements here, so we do that 9 times. Start crossing all of that 9 different times. Now what's a cofactor? So cofactor is the next thing we want to do now. Now a cofactor is, you could just do the rest, here, although we'll be doing it later on. The remaining 6 elements, you could just get their minus. They're minus. Now cofactors are minus with designated signs. So whether plus or minus with designated signs. Now the formula for it basically, so if we have C, alright. I make use of rule and columns usually. So CRC, for example, is going to be equal to, this is the formula, minus 1 to raised power R plus C. Then you have the minor that you're talking about, MRC. Now in textbooks, or if you are checking your browser or any other thing, rows are usually represented with this sign I, and C is represented by J. So this is now rewritten as Cij, right, equals minus 1 raised power I plus J, okay, Mij, which is essentially the same thing. Now what we observe here, from what is on the board, whenever I plus J is even, the cofactor is going to be equal to the minor. Now what I mean is, let's say we have C11, for example. So C11 is going to be minus 1 plus 1, right? Then M11. Now this simply means C11 equals minus 1 square, right? Then M11. And this is going to be minus 1 squared is 1 into bracket M11, and this is what? M11, which is, you understand what I mean? Now if this were 2 plus 2 as well, so that would be minus 1 raised to power 4. Minus 1 raised to power 4 is still 1, okay, and that makes the cofactor, and what did I say? But that makes C22, alright, the cofactor with dimension of 2 is going to be equal to the M22, and on and on. And by extension, so whenever I plus J is odd, alright, we then realize that the sign of the cofactor and the corresponding minor is going to be different. It's going to be different. So, for example, okay, I've already solved C11, right? Okay, so we can, so it's not a big deal. Here we did M12. So for us to get C12, for example, so C12 is going to be equal to minus 1 plus 2, then M12, right? So minus 1, this is minus 1 raised to power 3, then M12, and that will give us minus M12. Okay, so that's just how to do it. Now there is actually a shorter way to find cofactors, which is different from all of this. So what we just have to do in that case is to have the set of our minor matrix. All these things that I was writing here initially. So if there were numbers, certain numbers, so we are going to write all of these minors. All right, this is M11, so that given us a definite number. So now this one has given us a definite number as well as this. So we have written everything inside another matrix, and that is going to be our minor matrix. So from there we then start to assign signs and all of that. So that is the next thing we are going to do, so that you are going to understand what I'm saying in a better light. This is our example. A equals this, so we have to find the minors and the cofactors of A. Actually, the question could just have been find the cofactors, simply because in trying to find the cofactors, you'd have obtained the minors anyway. Alright, so what do? We start to do our crossing out. Recall that this is A11, A12, A13, okay, A11, A12, A13, on and on like that, A21, A22, A23, and what have you. So what we are going to do now is our M11 is going to be, we cross this out, right? When we cross this out, we are left with, we cross this out like this, we are left with 1, 4, 3, 2. So we left with 1, 2, 3, 4. Alright, and to find the determinant will be 4 multiplied by 1 minus 3 multiplied by 2, which is going to give us a minus 2 because this is 4 minus 6. Now that's that about that. Then how about M12? M12, that's going to be, so we have this, we cross this out, the middle column and then the top. So we'll be left with 4, 2, 5, 4, 4, 2, 5, 4, and this is going to be 4 into bracket 4, right, minus 5 into bracket 2. 4 times 4 is 16, 16 minus 5 times 2 is 10, 16 minus 10 is 6. Then we have our M13, so let's just deal with the first, let's deal with the first row, right, first row. M13 is going to be, so we take this out, this is where A13 is, right, and we take this out as well, so we'll be left with 4, 5, 1, 3, we'll be left with 4, 5, 1, 3, and this will be equal to 3 into bracket 4 minus 5 into bracket 1. 3 into bracket 4 is 12, 12 minus 5 times 1 is 5, and that is 7. So we have minus 2, we have a minus 2, 6, and 7. That's not all. So we then move to M21, right, which is talking about the second row and the first column. So we have this, and then we take this out. We have this, and we take this out. So we'll be left with 3, 1, 3, 4. So we have 3, 1, 3, 4. So we say this is 4 into bracket 3 minus what? 3 into bracket 1. Right, so 4 times 3 is 12, 12 minus 3 is what? 9. Then M22, you have to be careful of the signs so that you don't, if you miss it here, then you are going to miss the cofactors definitely. So M22 will be, we take this middle column out, so we take the middle row out as well. So we left with 2, 1, 5, 4. So 2, 1, 5, 4, and that is going to be 4 into bracket 2 minus 5 into bracket 1, that is 3. 4 times 2 is 8, 8 times that is 3. Then we move to M23, so which is this, and then we take this out, we take the last column out, and we take the middle column out. So we have 2, 3, 5, 3, we have 2, 3, 5, 3, and that's going to give us 3 into bracket 2 minus 5 into bracket 3. So I think this is 6 minus 15, right? And 6 minus 15 is minus 9. Then we move to M31, M31, so which is third row and the first column. And this is the third row, this is the first column. So we take this and we take this out. So we are left with 3, 1, 1, 2. So we have 3, 1, 1, 2, so this is going to be 2 into bracket 3 minus 1 into bracket 1, and that is 5, that is 5. Alright, then we move to M32, so M32 is going to be, so this is here and here, this is the position of A32, so the corresponding 32 is take this out and we take this out. So we are left with 2, 4, 1, 2. We have 2, let me do it again. Take this and we take this out. So 2, 4, 1, 2, 2, 4, 1, 2. So this is 2 into bracket 2 minus 4 into bracket 1, and that is 0. Then we do for M33. So M33 is going to be, so we take this and we take this out. So we have 2, 3, 4, 1. 2, 3, 4, 1. And this is going to give us 1 into bracket 2 minus 4 into bracket 3. So 2 minus 12 is going to give us a minus 10. 2 minus 12 is going to give us a minus 10. So we are done. So what we just have to do is to arrange this. So we have a cofactor, we have a minor matrix. So minor matrix M11, M12, M13, minus 2, 6, and 7. So this is going to be minus 2, 6, and 7, followed by 9, 3, minus 9, followed by 9, 3, minus 9, then followed by 5, 0, minus 10. So 5, 0, minus 10. So this is our Alright, so this is our minor, this is our minor matrix. So how then do we find our cofactor matrix? So we just say this is the minor matrix. So our cofactor matrix is going to be, we start using that formula, the formula that says Cij equals minus 1 Ki plus j, then Mij, right? So Cij for this is M11, right? So this corresponding C11 is going to be minus 1 into brackets 1 plus 1, then this is minus 2, and minus 1 raised to power 1 plus 1, this is minus 1 squared, that's 1. So 1 into bracket minus 2, which is also what? Minus 2. Now you could see what I was trying to say the other time, that when I plus j is even, the cofactor is going to be equal to the minor. Okay, so we do for this guy as well. So we have C12, right? C12 is going to be minus 1 raised to power 1 plus 2 into bracket 6. And that will give us minus 1 into bracket 6, which is what? A minus 6. Now, instead of continuing this way, there's a shorter method that we could use, which is just to designate. We said that cofactors are minus with designated signs, a plus and minus signs. So we just call this, that's a minus 6 over there, right? So just here is going to be a plus. There's a plus on M11. This is a minus. This is a shortcut. This is a plus. Now this plus minus plus. So next thing I have is minus plus minus, and then we have a plus minus plus. Okay, so now we can easily get our cofactor matrix from here. Please don't mix up the signs. Plus minus plus, alright, then minus plus minus, then plus minus plus, or something like that all the time. So here it's just plus times minus 2. Plus times minus 2 is minus 2. Minus times 6 is plus 6, right? So minus times plus 6 is going to give us minus 6. So this is, we have minus 2 using the formula, we have minus 6 here, so which means we are right. Then plus times, this is plus 7. Minus times plus 9, this is minus on 9. 9 is same as plus 9, so minus times plus is minus 9. So we'll be cutting like that. This is 3. This is going to be 9 because this is minus on 9. So minus times the minus and 9 is carried before. So minus times minus is plus, then 9. So this is 5. There's nothing like minus 0, and this is minus 10. So this is going to be our cofactor matrix. Okay, this is our cofactor matrix. Now we then move to the transpose, because we are trying to look for the adjoint. Now adjoint is simply the transpose of the cofactor matrix. So that is just it. Now what does transpose basically mean? So let's just digress a little bit to explain what transpose means. So transpose is all about turning an entire row into a column, or turning an entire column into a row. So if you have set B, for example, matrix B, for example, to be 1, 5, 9, all right. So the B transpose is going to be 1, 5, 9, something like this. So that's just what it means. So it's changing an entire row into a column, and that's what we are going to apply here. So the adjoint of matrix C, the adjoint of the cofactors is same as the transpose of the cofactors. All right. So series power T, or whatever textbook we are using, denote it with, and this is going to be, so minus 2, minus 6, 7 will now be on the column. Minus 2, minus 6, 7. And then minus 9, 3, 9 will be on the next column. Minus 9, 3, 9. Then 5, 0, minus 10. 5, 0, minus 10. You're done. So that's how to find the adjoint of a matrix. The adjoint of a matrix. So let me see. Minus 2, minus 9, 5, minus 6, 3, 0, then 7, 9. Okay, so we are right. So that's how to find. Now I'm going to give you an exercise. So the exercise states that you should find the adjoint. Okay, given matrix A as this, 1 minus 1 minus 1, 2, 3, 8. Should I make it this simple? No, I think I should do something. I think I should change this. Alright, I think I should change this. So we're having 0.1 minus 0.1, okay, minus 0.1 as well, then 0.2, 0.2, 0.3, 0.8, and minus 0.3, 0.2, and then 0.1. I don't think this is a right stochastic matrix. It is not. Alright, so given this, then find the adjoints of matrix A. Okay, so this is adjoint of matrix A, rather, don't mind me. Adjoint of matrix A is equal to the transpose of the cofactors of A. So given this set, given matrix A as this, so we have to find the adjoint of matrix A. So that's not about that. Whatever answer you get, please make sure that you leave them in the comment section. I believe you know how to space it. Some of our students have been leaving comment notes and putting matrices in the comment section. Alright, and I really like that. I really commend them for that. So if you have any question, please make sure you put them in the comment section. If you want to commend us for what we are doing, please do that as well. Share this video with your friends, your colleagues in school, your juniors, your seniors, and every one of them. And make sure you click on that like button. This is a good video, right? You like this video, right? Don't you like it? You enjoy it, right? So please click on that like button and click on the subscribe button as well if you haven't done that before. A notification bell appears afterwards, so click on that. That tells you when we release more of our classes. I would like to see your face next time. Am I the one seeing your face or you are the one seeing my face? Whatever happens, we would like to see each other's faces next time. See you then.